Yes, I am audible.
Yes, sir.
Yeah, let me start. Basic introduce yourself and will be discussed.
Good afternoon, sir. My name is Shubhradeep Sarkar. I am 23 years old. I live in Murshidabad district, Murshidabad in West Bengal. I have done my secondary and higher secondary in Berhampur Jain Academy, and I have done my bachelor's and master's from Ramakrishna Mission Residential College, affiliated to Calcutta University. At my master's, I got a project experience of 5 months where I am completely connected with laboratory, and after that I have done some excess work in labs. My strengths are I'm a quick learner and curious, and my hobbies are into playing crickets and into physical fitness. So that's about me, sir. Thank you.
Yes, good. The last day we have discussed two topics, chemical kinetics and coordination. Yes, no?
Yes, sir.
Today next move on GOC. Yes. What the main application of organic chemistry?
Sir, in case of our chemistry, organic chemistry has a huge part to study, because the organic chemistry is based on the carbon-like compound, carbon containing compound, and the number of organic compounds in our world is much more than the number of compounds in inorganic chemistry. So if there are plenty of organic compounds, then we have to study more in this case, and by the time we are doing research, and we get many things which are useful due to the study of organic chemistry, and we can understand better the actual concept of chemistry through the organic chemistry. So in this case, I have chosen the topic GOC, which is completely the basic information or basic concept of organic chemistry, which is very useful to understand mildly, or to intercept into the topic of organic chemistry, which is a very good topic to discuss.
Yes, good. First of all, the resonance effect. Yes, what the main application of resonance effects?
Sir, resonance is a complete delocalization of pi electron throughout cyclic ring. So in this case, resonance is very much important, because the delocalization of pi electron provides an extra stability to the compounds. And from the resonance concept, we can see that we can make many canonical forms of a certain compound, which are imaginary, which is not possible to distinguish in our real life, but still we can make some canonical forms which provides a hybrid structure. And by studying the hybrid structure, we can see, or we can get many knowledge about the molecule, which in the first phase we cannot see or cannot understand. Like in case of, we use the example for benzene, where we can see that there is a 3 double bond present in a benzene ring. So this is a single bond, and this is a double bond. So what will be the distance of what will be the bond distance in case of single bond? It is 1.454 angstrom, and in case of double bond, the bond length will be 1.2 angstrom. But when we check that experimentally, the bond distance between two carbon atoms in case of benzene, we see that the bond distance is 1.39 angstrom. So why? this concept is explained by resonance. Resonance tells us that the pi electron which is present in the benzene ring are continuously delocalizing, and every bond in this ring acts as a double bond. Not completely double bond, partially double bond character is present in all the bonds in this case. So this happens by the resonance, which shows that there is a hybrid structure which shows the delocalization of electron in the benzene ring and supports the experimental value which we get.
Yes, good. What the main purpose of resonance in chemistry? What the uses of resonance and resonance effect in chemistry?
Sir, in case of the application of resonance, we will say by the concept of resonance, we can understand the stability of molecules. So, what is the stability? Stability is a property of a compound which ensures how much energy it contains itself. When a compound contains very less energy, we will say that it is very stable, and when a compound has more energy or heavily excited molecule, then we will say that that is in a very high energy and that the compound is unstable. So by the application of resonance, we can predict the actual stability between many compounds. Like if we say, or if we take some example, then we can identify that there is some stability difference. If there is some stability difference in molecule present, we can understand by the resonance theory. So in this case, in benzene, there is always resonance is taking place, and in this compound also there is a possibility of resonance, and in this compound there is also a possibility of resonance. So by the concept of resonance or conjugation, we can understand which of the following compound is more stable or which is the following compound is less stable. So in this case, we can predict the stability of a structure by resonance using some rule, which is the number of pi bonds. Firstly, we check the number of pi bonds in the molecule. Then we check that fully filled octet. If there is a fully filled octet, then that compound will be more favored as stable compound. And if negative charge is on electronegative atom, that will be a stability criteria, and also charge separation is closer or near. So this is the criteria by which we can predict the stability of a compound. In this case, we can see that the benzene ring is a highly resonated compound and it has more stability than these two because it has 3 pi bonds. In this case it has 1, and in this case also it has 1, but it has negative charge on a non-electronegative atom, and in this case this is a positive charge of electronegative atom. So this is how we can predict or apply the resonance theory to understand the stability of organic molecules.
Yes, good. Next, move on inductive effect. What the main application of inductive effect? What the purpose of inductive effect in organic chemistry? What the uses of inductive effect in reaction mechanism and organic chemistry and chemistry?
Okay. So, sir, inductive effect is a permanent effect in a organic molecule, and inductive effect is basically the sharing of electron, not the sharing of electron, but it is actually the partial displacement of sigma electron. Partial displacement of sigma bond is called as inductive effect, and it happens due to the difference between electronegativity. So in this case, we can see a compound which is CH3CH2CH2Cl. In this compound, this is an electronegative atom, and by the presence of electronegative atom, there is a polarity emerges, and charge separation involved. So to reduce the strain in this case, in this molecule, this part, or the CH3CH2CH2 part, this will donate its electron or displace its electron towards the Cl atom. So there is electronegative difference presence here, and displacement of partial displacement of sigma bond or sigma electron occurs. This is called inductive effect. This is called inductive effect, and this inductive effect shows us if a electron, or if a group, or if a species will act as electron withdrawing or electron donating. So in this case, electron withdrawing group is Cl, and it is showing minus I effect behavior. But the CH3CH2CH2 part, this part is donating its electron, so it is showing plus I effect behavior. This is the main application of inductive effect in organic chemistry. We can understand the displacement of electron and study the true nature of a molecule.
Yes. Next, move on mesomer effect. What the main application of mesomer effect? Uses, purpose, applications.
Okay. So mesomeric effect is basically an effect, and more stronger effect than inductive effect. It is also related to the electronegativity difference in the molecule, and in case of a species which is connected to a moiety of a molecule, then if it will donate its electron towards the lower electronegative, towards the higher electronegative part, then it will called as mesomeric effect. And when an electron withdrawing group is attached with, let's say, benzene, and electron donating group is attached, so when electron withdrawing group is attached, it will take the electron density from the benzene molecule. But when an electron donating group is attached, it will donate electron to the electron moiety of the benzene molecule. So this case is called actually the mesomeric effect. And when an electron donating group showing the donation of electron towards the benzene, then it will be called as positive mesomeric effect. And when electron withdrawing group is withdrawing the electron from the benzene ring, then it will be called as negative mesomeric effect.
Yeah, next move on hyperconjugation. What the main application of hyperconjugation?
Hyperconjugation is also a similar like effect of like mesomeric and inductive, but in case of hyperconjugation, there are some system which is needed for to occurring hyperconjugation in a molecule. First condition will be an alpha hydrogen is present. So in a compound, if we see that like this, so in this case we can see alpha hydrogen, 3 alpha hydrogen is present. So when this type of molecule is present, this can be CH2 plus, this can be CH2 dot free radical, this can be double bond, and this can be pH ring also. If alpha hydrogen is present, then this vacant orbital of the CH2 plus, the electron of electron density will share to the vacant orbital, and the number of alpha electron, if the number of alpha electron is more in the case of molecule, then the chances of donation of the electron will be more. So this is why the number of alpha electron in alpha hydrogen is more, then the stability of the compound is more. So this process is called as hyperconjugation. In this case, when it will this electron, then it will make this like structure, and similarly another will be this like structure. So this is the actual hyperconjugation occurring in a system which affects the stability of a molecule, and when it is increasing the stability, then it is called the plus H effect, and when decreasing the stability, then it is called minus H effect.
What the difference between resonance, inductive, mesomeric, hyperconjugation?
So every process is different from each other, where we can see that in hyperconjugation there is a complete donation of sigma electron occurs, and in case of inductive effect, partial displacement of sigma electron occurs, and in case of resonance we can see the complete displacement or delocalization of pi electron is occur, and also in case of mesomeric effect the non-bonding electron or the electron which presents in a group as a lone pair, this will donate or this will be withdrawn from a molecule. So these are the fundamental difference between hyperconjugation, mesomeric effect, inductive effect, and resonance.
Yes, good. The GSC is next move on intermediates, basic. What is intermediates? What the main purpose of intermediate in reaction mechanism and chemistry?
Okay. So intermediate is a compound which produces in between a reaction and doesn't appear in the product. It it is basically a short-lived, very short-lived species. It is basically the product of a reaction or a series of reaction and a reactant of the next reaction. So according to the energy profile diagram, we can identify when an intermediate is appearing in a reaction. So here we can see this is A, which is reactant, and this is C, this is the product. In this case, we can see there is a hump in this case. This is the place of intermediate, and in an energy profile diagram, it is somehow stable, but not that much stable that it will live forever and it will be the ultimate product. Intermediate's work is to produce itself to a certain extent, and then it will convert to the ultimate product. This is the main application of intermediate in organic chemistry.
Yes, good. Yes, what the difference between carbocation, carboanion, and carbonium ion?
Okay, so sir, in case of carbocation, we can see it is produced from a heterolytic cleavage. Heterolytic cleavage, it contains 6 electrons and it is sp2 hybridization. It has sp2 hybridization and it is trigonal planar. With adding electron donating group, the stability of carbocation will increase, and adding electron withdrawing group, the stability of carbocation will decrease. And in case of free radical, this is also a type of intermediate which produces in the reaction, and it is also called as a reactive intermediate. This is produced from homolytic cleavage, the equal distribution or equal cleavage of a sigma bond. It contains 7 electrons. It is also sp2 hybridized, and the shape is trigonal planar. But what is carbanion? Carbanion is also from heterolytic cleavage. It has 8 electrons and it is sp3 hybridization. It has 8 sp3 hybridization and its structure is pyramidal. So these are the types of reaction intermediates which we can see in many organic reaction mechanism which follows to the ultimate product.
Yes. Next, move on. What the main application of nitrine, carbene? What the difference? What the uses? Explain both one.
Okay. So carbene is a structure which can be written as like this. This is called carbene. It is also a reaction intermediate. It contains 6 electrons and it has 2 electron in its valence shell. So there are 2 types of carbene. One is singlet carbene, one is triplet carbene. So what is singlet and what is triplet? When the 2 electrons present in one orbital, then it will be called as singlet carbene. And when 2 electrons are present in 2 orbitals, then it will be called as triplet carbene. Triplet carbene are more reactive than singlet carbenes. And why it is called singlet? Because the spin multiplicity 2s plus 1 is 1 here. So this is why it is called singlet. And in this case where 2s plus 1 is basically 2 into 1 plus 1. So it is 3. So this is why it is called triplet carbene and this is called singlet carbene. And the use of carbene is to produce many compound which are morely photochemically active. This type of reactions are occurred through carbene mechanism, where you can produce a carbene from CH to N2 by using sunlight. It will break the bond and create carbene, and nitrogen will evaporate. This is the carbene and
Bond angle, hybridization.
The hybridization for singlet carbene is sp, and in case of triplet carbene the hybridization is sp2, and the bond angle between the carbene for triplet carbene, the bond angle is 110 to 120 degrees.
Yes, any reaction of triplet carbene, singlet carbene and nitrines? Any reactions?
So the Riemann reaction, which occurs in a basic medium with the use of chloroform and phenol, it will produce CCl2, which is a triplet carbene. In this case, CCl2 attacks to the benzene ring and attaches to the benzene ring. Then after the hydrolysis, it will form COH, which is finally formed the CHO. This is a reaction of triplet carbene, which is a famous name reaction. It's called Riemann-Tiemann reaction.
Yes, good. Next, free radical. What the main application of free radical?
Sir, free radical is a reactive intermediate which consists 7 electron and it has sp2 hybridization. It is trigonal planar, and in case of reaction which occurs through free radical mechanism, then we will use the example of the example of BARC reaction or Wurtz reaction. So in this case, two free radicals are produced throughout the reaction, and by giving their single electron, it will form a bond between R and R, where first we have used RCl and RCl, then using sodium ether, here the formation of free radical occurs, and then we will finally get the product. This is the application of free radical mechanism. There is also many reaction which follows free radical mechanism, like Kolbe electrolysis, Wurtz reaction, Ullmann reaction, Wurtz-Wittig reaction. This type of reactions are done through free radical mechanism.
Yes, good. Next is benzene. The main application of benzene intermediates. Benzene. Explain.
So this is the structure of benzene. In this case, we all know that when a triple bond is present, then the bond angle must be 180 degree. But in this case, that 180 degree is not possible. But still, this intermediate forms in a reaction as a reactive intermediate, and it has 180 degree, not the exact 180 degree angle, but somehow close around that, and it will use, because it is a triple bond like structure, it is not the actually triple bond like structure. So the the hybridization of this carbon which is used in benzene is sp2, and in many reactions we can see benzene intermediate are using or producing a benzene intermediate, and then further the reaction product is emerging. So like an reaction where we use a chlorobenzene plus NaNH2. In this case, Cl is getting out. Here this bond will produce itself, and then This is how the benzyne intermediate forms, and then NH2 minus attacks. This type of product will form. This is an example of benzyne intermediate reaction, which is further produce two types of product like this. This is if we mark this carbon with a star, then it can be like it can be produced two types of product. It is called ipso substitution.
Yes, what the region of sidewise overlapping of triple bond, double to and hybridization of sp2 sp2. Two p orbitals, both carbon atom.
What is the
region, what the effect of carbon atom to sp2 sp2 hybridize? Yes, no?
sp2 hybridization means there is a double bond present in the molecule, which is basically done by the sidewise overlap of two orbital, and the sidewise overlap creates the pi bonding. This is why we can see double bond in a molecule in which sidewise overlapping occurs. And excess bond, which is a double bond. In this case, one is sigma bond and one is pi bond. So the pi bond was made by the sidewise overlap, and the sigma bond is made by head-on overlap.
Yes, good. Yes, any drawback of GOC and intermediates? Any limitation in organic chemistry? Explain.
Yes, sir, there is some drawback maybe, because in case of intermediate, it can form other products or other byproducts which are not desired in our chemical reaction, and in intermediate it delays the reaction somehow by the production of intermediate. It delays sometimes the reaction, and sometimes it can help the reaction to become faster, because there are some